Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Hi everyone, my name is Daniel Stafford. I'm a PM on the Windows Phone Developer Platform team. And today I'm going to talk about the tools for Windows Phone 8 and what's new. So what is new? We now have tools and templates for native and hybrid applications as part of Windows Phone 8. We did a big push for native, so now there's actually tools and templating to go along with that. There's also debugging improvements, and this is mostly around native again. Improved profiling, which includes a new app monitor, and emulator improvements, including Hyper-V, and also a simulation dashboard. So we've added a bunch of different project templates, and to show this, I'm actually going to go into Visual Studio. So if we go to File, File, New, Project. Under Visual C# here, we have the Windows Phone node. And now there's a couple new templates. First of all, we have Windows Phone XAML and Direct3D application. So this application actually uses a drawing surface as its starting point, which is drawing surface is just like any other XAML control. You can use it behind, in front of, or side by side with another XAML control. And it basically just renders D3D graphics. The D3D graphics that are actually rendered will be in a separate runtime component. Also, in the Visual C# node here, we have the HTML5 application. But don't get too excited. This is not WWA or anything. This is actually putting a web browser control on a page and then rendering HTML that's part of your application. Under other languages, Visual C++ here, there's now a new node for Windows Phone, which includes a Direct3D with XAML application. So we saw the other one. This one is actually using a drawing surface background grid, which the difference is that it has to be at the root of the XAML tree, and it covers the entire surface all the time. So the D3D component is still in a separate runtime component, but the frame rate for a Direct3D with XAML application is actually a little bit better than the XAML with Direct3D application. Also, another difference is the fact that the XAML with D3D application is to use XAML controls along with your project. This actually is a very thin client on top of a essentially native game. So this is more if you want to take advantage of some things that are only in the managed stack, like live tiles, background transfer service, or launchers and choosers and such. There's also a native-only choice. So that choice is basically entirely D3D. So if you want to add any controls or anything, you have to do everything yourself or use third-party libraries. And then the other stuff is just runtime components, DLLs, static libraries, etc. So also, there's the Manifest Designer. So the Manifest Designer is basically a more friendly UI to the WM app manifest.xml file. So I'll show you that. So if we use this project that I've already created, which is just the basic XAML with D3D application, under the properties here, we've got the WM app manifest.xml. And so this is the new designer for that. It allows you to do a lot of stuff like the display name, the supported resolutions, any app icons, etc., etc. It also allows you to set the capabilities. If I can. So the capabilities are basically anything software related, so access to the location-based services or microphone, camera, or sorry, not camera, well, yeah, camera as well, maps, etc., etc. And also, as part of this, you can click on it and see the description. A lot of people tend to set all of these because they're having an issue with access, and personally, I would recommend that you only do the ones that you actually really need, because when someone downloads it from the App Store, it's going to show all of these capabilities as part of your thing. So There's also the Requirements tab. So this is basically the hardware requirements that you have to meet to actually be able to download the application. So this includes things like NFC or rear camera or gyroscope, etc. And then lastly, there's packaging. Packaging allows you to set the version number for your application, and it allows you to say what languages you support and what the default language is, and etc. So there's also a simulation dashboard. So this allows you to actually basically simulate real-world scenarios. So for example, a lot of people have issues where they're going in and out of cell range, or they're switching to Wi-Fi or something like that. And I've personally even used a lot of applications that tend to not handle those scenarios very well. So this is basically a tool that you can use to try and simulate those situations, moving different data networks or something like that. It also allows you to trigger reminders. So the reminders, are just the little slide that comes down. And it also allows you to simulate a lock screen. And that can be found under Tools and Simulation Dashboard here. So next is the debugging. So as part of this, we've enabled native. So we wanted to also enable debugging native, obviously. So in the property pages of your application, you can set whether you want the UI task to be managed or native. And you can also debug a background agent. And you can set these independently. So you can debug the managed part of your UI task and the native part of your background agent if you want. You can also debug both a background agent and a UI task in the same debugging session. So you don't actually have to switch back and forth. However, there is no mixed mode debugging, so you can't like F11 into your native code. You have to choose one or the other. Also, the debugger stays attached after you've exited the application. So if you start the application, press back, and then the debugger will still be attached so that you can try to launch your application from a live tile or from a push notification, and then it'll continue the debugging session. Also new with Windows Phone 8 is the fact that we compile in the cloud now. So Visual Studio compiles into CIL, which is Common Interface Language. This used to be known as MSIL. It's pretty much just a name change. Apps, when they're submitted to the store, they get converted into MDIL, which is Machine Dependent Intermediate Language. And then once the application is downloaded by an end user, the MDIL actually generates a native image depending on the device. So this is good for users because of the fact that it runs a lot faster, and it's good for us because we don't actually have to generate native images for every single possible phone that comes out. But also it has the caveat of not being able to debug as easily. However, you can debug a native image. It's just not supported in the emulator, so you have to use a real device for this. If you run without debugging on a phone, it actually will already run the optimized native image. If you want to debug the native image, you have to go to Tools. Here, I'll actually just show you in Visual Studio. You go to Tools, Options, and then in Options, there's Debugging here. And debugging has a couple options, one of which is Enable Just My Code, and also suppress JIT optimization on module load. If you uncheck both of those, then it will actually load the native image onto your phone, so you can debug while using the native image. So there's a bunch of emulator changes, the biggest of them being Hyper-V. So Hyper-V is the new platform that the emulator is built on. What this means to you is that you have to actually have a computer that's SLAT enabled. So there's a tool called coreinfo.exe under C Windows System 32, I think. It will basically tell you what your computer allows, or what your computer's capabilities are. And so it'll tell you if your computer's SLAT enabled or not. There's also different ways to find out, like for example, you can go into the BIOS, and usually there'll be a little thing in your BIOS that tells you whether you can do virtualization or not. So that has to be enabled for Hyper-V to actually work. And also, as part of the install for the SDK tools, it'll tell you whether Hyper-V is turned on and if your user was added successfully to the Hyper-V administrators group, which it has to be part of that to be able to set up the next part, which is networking. So the networking stack in the emulator is actually a bit different than it used to be. To understand the capabilities of the emulator's new networking stack, you can think of it kind of like a Windows phone basically attaching to the same network. So if there's a network resource that you're trying to actually hit, if your Windows phone attached to the same network can hit that network resource, then the emulator will be able to as well. The emulator does require that you have DHCP on your network because it will actually attach itself as a separate device and get its own IP address. It's also not possible to set the DNS and gateway settings on the emulator manually, unfortunately. It'll copy the proxy settings from the host machine, though. So if you have a proxy server set up on your network, it'll automatically configure itself. It should be fine. It now supports multiple resolutions. So there's WVGA, WXGA, and 720p. So all of the resolutions that Windows Phone 8 ships in, you can now test in the emulator. And I would recommend that you actually do test in all of the resolutions to make sure that any of the applications that you're developing, all users can actually see everything well and have a good experience. The camera now supports photo capture device and audio-video capture device. These are two classes that are used to enable some external situations if you want to take control of the camera settings yourself, like ISO, contrast, brightness, etc. So it allows you to set a lot of that stuff so you can have a more rich camera experience. And the camera in the emulator does support that. It doesn't use your webcam or anything still. It still has the lovely little blinking box around the border. And lastly, there's graphics changes. So we've actually switched to software rendering as opposed to the hardware-enabled rendering that the old emulators used to do. What this means is that it'll look a little bit slower, so anything that you have that's animation intensive, or if you're running a game or something like that, you'll definitely want to run it on the device as well, just to make sure that it's actually running smoothly. So app monitoring allows you to collect a lot of key metrics based on the quality of your application. Things like events, frame rate, CPU, app responsiveness, battery consumption, storyboards, image loads, and garbage collection events. A lot of this data is then compiled, and basically it'll analyze the data and give you an actionable list of things to do based on the data. So, for example, you can see over here that we have startup time, resume time, and responsiveness. And so if your startup time is between 0 and 5 seconds, it'll continue to be green. If it has anything past that, then it'll warn you that your startup time is a little bit too long. So you should probably, take it easy on your textures or something. Resume time has to be within 0 to 2 seconds for it to be considered green. And that'll actually only show up if you resume your program. So if you press the Windows key and then back or something like that. Responsiveness is based on UI stuttering and latency. And then it also gives you a lot of other data, like the data uploaded, the data downloaded, the battery charge remaining, memory used, and the average memory used. So now I'm going to show you a demo of the app monitoring stuff. So here we've got an application. It's a pretty simple application. It's basically just got a couple buttons and a canvas, if the designer loads. There we go. And basically, when you click on the button, the code here will actually, sorry, I have to make it a little bigger. There we go. So the code here will basically create a bunch of new bubbles, set them at a random point on the canvas, and then add some animations. The animations here I've specifically set as CPU-bound animations, so they're dependent animations. It's animating the width and the height at random intervals and a random time span. The reason I did this is to tax the system as much as possible so you can actually see what's going on. So we can start an app monitoring by pressing Alt F1, or you can also go to Debug here, and then there's Start Windows Phone Application Analysis. So basically what you need to do is just start the session, which will start up the emulator. Hello. Oh, emulator's on the other screen. So here we've got our application. So if I basically do some bubbles, more bubbles, eventually the UI starts to stutter. So, and in a normal situation, this could be something like, list box blinking, or if you have a lot of animations or something going on, it could stutter. So then you can end the session, and then basically this will copy the log file, parse it, and then analyze it. This can take a long time depending on how long you've actually done your app session. In this instance, it would probably take about 30 seconds. So I actually already have an app monitor log here that I ran a little bit earlier. So you can see here that our startup time is fine, but our responsiveness is poor. So we have two alerts up here. So we can see that the first alert is very low frame rate from 21,270 to 21,570. And then we also have high battery consumption. So you can see here that our frame rate is kind of halting a little bit, and our CPU usage is incredibly high. So if we actually select a time span, which will give us more information about that specific time range, you can see here that we have low frame rate because of the fact that we have CPU-bound animations. So because we have a lot of dependent animations on the screen, it's taking a long time to actually do these things. So it's causing the frame rate to drop significantly. Another very interesting part about this is that we can see the frames of that specific time frame. And we can see based on certain things like CPU usage. So CPU usage is a very useful one in this instance because we're peaking a lot. So you can see here that this specific frame is at 25% CPU usage, which is really high. So we can see certain things about that frame, like we can see the entire visual tree for that frame actually. So this will tell us what is going on in that frame. So you can see here that we have all of these controls and all of that. And it'll also tell you what's being drawn to the screen and what's dirty and what needs to be remeasured. So you can see here that everything basically needs to be remeasured because of the fact that we're using a dependent animation for width and height, which are both layout based, which means that they run on the UI thread. So also, as part of this, you can see things like the battery consumption. So our battery consumption got pretty high when the animation started, and then it tailed off at the very end. So this is useful for things like, if your app is really using a lot of batteries because it's loading a lot of textures or something like that, you may want to check it out because a lot of times users don't like that kind of stuff. Another thing it'll tell you is memory usage. So you can see here that the memory usage steadily spiked, which is what we expected. And then it'll also tell you things like when storyboards start. So here you can see that we do have a bunch of storyboards and they're CPU bound. And it'll also tell you the start time and the duration of the storyboards. It'll also tell you when you have image loads. So I loaded just one texture for the bubbles, so that's why it just shows one. And it'll also show you all of the garbage collection events. So with that, it's Q&A.
My question here is, how much of this is enabled with the Express queue?
Okay, so the question was how much of this is enabled on the Visual Studio Express SKU. Actually, all of this is enabled, I believe, on the Express SKU.
Wow.
Yes?
Are there any plans to add a unit test framework?
Are there any plans to add a unit test framework? I can't answer that one. I don't really know. So if you send me that question in an email, I'll try and follow up with that for you. Yes?
Stupid question. What is a storyboard?
What is a storyboard? A storyboard is a XAML animation. So it's basically telling the XAML framework what you want to do and how long you want to do it. So I'll show you an example. So in here, we have a storyboard declared at the top here. So it's storyboard SB here. And then down here, we're basically doing a double animation. So we tell the storyboard what the target is. In this case, it's the element that I want to actually animate the width. And then we also set the target property, which in this case is the width property. We tell it what value to do it from and what value to do it to. So in this case, we're animating it from 25 pixels to 100 pixels. And then we also tell it what the begin time is, the duration, and if you want to auto-reverse it, and repeat behavior. There's some other things that you can also do, but this is most of the stuff that you'll actually ever use. Yes, begin time is basically what the time in milliseconds to actually begin after this point. So you can basically delay animations to start after a different animation. So say, for instance, I wanted to animate the width and then the height. I can set the begin time for the height animation to be the length of the duration of the width. Does that make sense? Yeah. So basically, then we just add those as children of the storyboard, and then we can basically tell the storyboard to begin, and then it will run the animation.
Storyboard is only for like animation stuff?
Storyboard is only for animations? Not necessarily. It's also can be set to do discrete keyframes. So what that means is that you can actually basically set properties at specific times. So you can actually do anything with it. You don't have to animate. You can actually set specific things. I saw a question back there.
I'd like to measure the network usage.
I'm sorry.
The network usage?
Yes, network usage. Network usage, you can't see like the individual data on this screen, but it will tell you on the summary page here. It will tell you how much data was uploaded and downloaded.
I think we just got the same question here. Is short of that, is any monitoring on the socket communication or anything like that? Or?
So about the socket communication stuff. So yeah, I don't think the app monitor itself will actually show you like any spikes in the network usage, but you can see at least the summary stats.
I mean, what I do so far, at least for my apps, is if I have to monitor just HTTP traffic, is I would just redirect the phone to Fiddler.
Mm-hmm.
Is anything else now, or I mean, this is still the route basically?
So basically, he's asking if Fiddler is basically the best route, which currently, yes, Fiddler is still kind of the best route to monitor network traffic for any phone apps that you're writing. Yes?
One of the screens showed frames. You were showing frames.
Yes.
Is the context of a frame an actual, 60-second segment of a screenshot, or is it talking about stack frames, or what is a frame in that context?
So a frame in this context is basically one tiny little unit of time. Yes.
Is everything sort of time sliced into frames in this profiler? Or is that?
Yes. So you can see up here at the top that we have this ruler. This ruler is basically the frames. So frame 238 basically has a start time and a duration. So you can see here, like, all of these have start times of very, very, very minuscule amounts different.
Why would they have different durations?
I'm not entirely sure on that one. I think there was a reason, but I can't think of it off the top of my head. I'm sorry.
It looks like the duration gets very small when the CPU drops, so it must be bound to how often the CPU.
Yeah, the profiler does run on the same thread, or it runs as part of it. Basically, it's side loading. So I think it's partially due to the fact that like when we have a lot more CPU CPU action happening, it won't run as often because of the fact that the UI thread is very busy.
Well, it injects markers into your code. So if there's more code running, you're going to have shorter frames. Whereas if something takes longer to run, it's going to have a longer frame.
So it instruments your code. So it's not a time slice necessarily.
I don't know too much of the details, but I do know there is some.
It's not like a static time slice, so it's not like 60 milliseconds every time, but it does represent a unit of work, a unit of time.
Another question is
Yeah, we'll do that one.
Okay, since we have different types of phones and screen sizes, so is there an easy way to set the controls width and height, because it's depend on the phone and size, so that control either it will hide or it will empty space it will display. So is there any easy way to identify the phone size and then automatically set the width or height to the control?
So the question is basically how to set control widths and heights based on the phone size. So the best way that I have found personally to develop phone or applications that actually target different sizes is to make it so that your application doesn't necessarily depend on exact pixel widths. So like for example, in this application, I didn't specify any widths or heights. So I actually used a grid and I defined a couple rows in my grid. So this one is defined as auto. So basically it's just saying use up however much space you need. And then the other row is set as star, which basically just says use the remaining space. And then my columns, I did the same thing. So it's basically splitting the screen in half.
Probably this is a simple grid, so it may work. So if you have like some complicated app and then like a lot of controls are there, so it won't work.
If you do have a complicated application, usually you can still get away with making at least part of your application use the rest of the space, essentially. So you might have parts of it that you have to have specific sizes, because they're an image or something like that, that it has to be the same size. But best practice is to make it so that you can have part of your application that just basically takes up the remaining space.
About this.
Yeah.
On the dev in Windows, then this is exactly how we do UI in Windows, because you don't know what screen you're going to end on. And if you hardcode it for something, like you may have a control that just doesn't show at a certain DPI or doesn't show at a certain scale or whatever.
Right,
so
and
that is the recommended way.
Yeah. So basically, he was saying, in Windows they do the same thing.
Back on the network, I don't know if you say that. Can we do anything monitoring with Netmon or?
Can you do anything monitoring with Netmon? I'm not sure on that one.
When you have the Hyper-V sitting in.
Yeah, due to the fact that it's a Hyper-V instance, which technically it's another instance basically within your computer and it's virtualized. I'm not sure if Netmon will work. It's worth a shot. Do you know?
If you're not using IPsec, so nothing on corporate domain, you're able to actually just sniff the traffic off the controller now. So you won't get both your desktop and the mobile.
Right, yeah.
Now you can just sniff the packet. Now almost everything can be sniffed from the network card. But you cannot sniff things over SSL. That's still not going to happen. So you won't be able to be man in the middle for HTTPS. But for sniffing the traffic, just tagging the network card's enough now. It's Hyper-V. I mean, it's the same.
Yeah, so you can actually just...
A lot easier now.
So basically you can set up like a Wireshark instance or something like that and set it to do the Hyper-V's network adapter.
Okay.
Any other questions? All right.
Cool.
Thanks, guys.
Thanks, Daniel.